Okay, I have something else I want to make this for, but I want to make a rainbow of colors in Python, in Glowscript VPython. So what I want is like a bunch of balls like that, where it goes red, orange, yellow, green, blue, violet. Just like that. Okay. So one of the things in Glowscript VPython that you need to know is that you can determine a color. You can pick a color, and I'm going to show you this in Python. You can say red, green, blue, whatever, cyan, magenta, but you can also describe it with a vector. So we have the three main colors, red, green, and blue, and we can represent that as a XYZ vector. So here's my idea. We want to start, so this is red, this is green, and this is blue. So we want to start with red, and then slowly turn into green, and then slowly turn into blue. So I think this will work. I'm not 100% sure. So the idea is like this. Suppose I have, call this green, red, blue. And so if I have a vector at some angle theta, as theta increases, it will become less red and more green. And then once it gets up here, it'll go from green to blue as I rotate this vector through that space. And that's what I'm going to do. Now, it's not just a normal vector, because you can see that here I have this left is red and the right is blue. So really, I'm going to do two loops. I'm going to have a vector going from red to green and then green to blue. Well, let's just jump right into Python and start working on this and get it to work. And like I said, this is really just for me for something else. And it's important to make it so you don't forget it. Okay, so I'm in Glowscript VPython. The first thing I just want to show you is the idea of a sphere. So, and a color sphere. So let's just make a sphere like that. And I'm going to run it. Seems like it's not big enough. Okay, so the default color is white, but I can make this any color I want. So let's say color equals color dot yellow. Yellow is my favorite. It shows up the best. Okay, now let's make this color equals vector 1, 0, 1. I don't know why I picked that. So you see now it has all the red and all the blue, and you get magenta. I could just do 0, 0, 0, and I get red. I could do 0, 0, 1, and it should be blue. And there you go. Okay, now, but what if I want to represent this with an angle? So let's do this. Let's say theta equals 45 times pi divided by 180. I need it in radians. And I want to do a halfway between red and green. Well, I can write that as a vector. I can write that as a vector cosine theta, sine theta, 0. So it's a projection into the red-green plane. Does that make sense? Okay, so that's what I'm going to do. I'm going to have my angle going from 0 to pi over 2. I'm going to have 0 to pi over 2. Yeah. And then I'll go from, again, 0 to pi over 2, but I'll do it in between the y and the z axis. It should work. Okay, let's start off with making a bunch of balls. So let's pick how many we want. I'm going to start with the simple one, something like 10. And I want the length of how long that is going to be. Let's just say that's 1. Okay, now I need to know the spacing between each ball. That's pretty easy. I'm going to move in the x direction. So I'm going to call that dx is just L divided by n. And the radius of each ball so that they'll fit. You could change this to whatever you want. I'm going to say dx over 2, right? Because that's the spacing between the balls, but the radius is half of that. Okay. Now I'm going to say I want my first starting point. I'm going to call it x start. It's going to be equal to negative L over n. No, it's negative L over 2, right? So if I want it to be centered at the origin, then I'm on the one side, it's going to be negative L over 2. Okay, so let's just go ahead and make a bunch of balls. So I'm going to say n equals 0, and while n is less than or equal to n, do the following. Make a ball. And so the ball's just going to have a position, sphere, position equals vector, x start times, no, plus n times dx, 0, 0, right? So I'm going to start off at n equals 0, and so it's going to start in the x value of x start. And the next time it's going to be 1 dx over. The next time it's going to be 2 dx overs, 3 dx overs, and so forth. And then my radius is going to be r. And then I'm going to increase n equals n plus 1, and that should do it. Let's see what happens. There. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say, if I do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's better. Okay, so now I have my balls. So the next thing I want to do is to make an angle theta going from 0 to pi over 2. Yes. Okay, so let's do it like this. I'm going to say theta is equal to 0. D theta. See, I only want to go halfway though. So I only want to make half the ball. So I'm going to go to n over 2. So I'm going to have d theta is equal to pi divided by n, right? Because I'm only going halfway. So I'm only going to n over 2. So this is going to go from 0 to pi over 2 by a theta amount, d theta, right? So I'm going to change the n in a little bit. So that's it. So I just need to go over here and tell it a color. So the color, not cooler, it is cooler. Color is going to be equal to the vector cosine theta, sine theta, 0. I think I got the 0 in there. I don't know why. Let's see. Yeah. Okay. And then I'm going to increase my value of n. I also need to increase my value of theta. So I'm going to say theta is equal to theta plus d theta. And this is just going to be half the loop. So it's going to be from red to green. Let's see if it actually works. Okay. Actually, that's actually kind of artistic and pretty. And I like that. It just makes me happy. Look at that. Okay. Now we're going to do the other half. So now I'm going to reset theta back to 0. And I'm going to keep on counting. So I'm going to say, I'm going to have the same loop. Copy that. But now I'm going to do it till n is less than n. And I'm going to say 0. I'm going to put the r value as 0. I'm going to get rid of this. And that should do it. Let's see what happens. I haven't even saved this yet. Rainbow color example. Let's run it. Okay, so there it goes. Red, orange, yellow, green, blue. I don't really have purple, but I'm fine with that. I'm fine with that. I don't know how you make purple. I wonder. I mean, this doesn't have to be perfect. It just has to be kind of good. And actually, that looks really nice. Okay, so let's go over here and let's increase this to, say, 50, just to see what it looks like. Okay, I'm pretty happy. Actually, let's do this. Let's do this. If I do this as 100, then the balls are going to be too small. So let's say the radius is going to be equal to, let's just do dx, and they'll overlap and see what happens. I like that. Let's say dx times 3. I like that. Look at that. Is that not cool? Look at it from this side. Look at it from that side. Nice. Okay, that's it. I'll put the code down below. And like I said, I wanted to do this. I was going to make a bunch of lines on a graph, and I wanted to pick the color. And that's why I'm going to make this one a way to pick the color from red to blue, the color of the rainbow. So it doesn't have to be perfect. I just want to distinguish. I don't have to manually pick all the colors. So that's pretty cool. Okay, so I'm going to give you this code down below, and maybe you'll find this useful, and maybe you won't. And I'm fine with that. I really made it for me.